Welcome to Made in Science, the official podcast of the University of Stuttgart. Today, we will be addressing the world of 3D computational geometry and architecture. That is the area which Dr. Gene Ting-Chun Kao is working in. Dr. Kao joins us from Stockholm, Sweden, where he is an R&D engineer at ANSYS company. At the University of Stuttgart, he studied in the master program ITEC, which stands for Integrated Technologies and Architectural Design. In our conversation, we will talk about the triple challenge of being a designer, engineer, and scientist. And we will talk about the role of technology in architectural design. And why cooking is like engineering. This actually is a quote from our guest. Welcome, Dr. Kao.
Thank you, Wolfgang. It's my pleasure being here, and thank you for inviting me.
Let us just start with what I said last. Cooking and engineering. How do you see the relation between these two? They seem to be very close in your mind.
Yeah, so cooking, it has to be like visually appearing, and also like it has to be delicious with all kind of ingredients. So you have to have like the right combination. It's more like engineering. So I think it's pretty much like engineering and art, yeah, in my mind. Yeah.
When you came to Stuttgart, you studied in the master program ITEC, which is for Integrative Technologies and Architectural Design Research. It is a very multidisciplinary, research-oriented, and experiment-based program that really shapes the contemporary aspects of the built environment. Now, through the advancements of technological and computational processes in architecture, the program serves to merge various fields like design, engineering, construction, and natural sciences. You came to Stuttgart with a bachelor's degree. The program itself is open for students in architecture, engineering, and natural science, and it is constructed in English. All of this sounds very interdisciplinary. Now, from which angle did you come to Stuttgart in 2014, I think?
Yeah, so yeah, as you described it, yeah, I went to Stuttgart in 2014. So before that, I studied architecture design back in Taiwan, and I always like enjoying programming, digital fabrication, and so that's how I found the program, and yeah, and then when I uh, get accepted from the program, then I moved to Stuttgart. Yeah, that's how I started uh, the the master program, and then I met a lot of people from different backgrounds. So yeah, it gave me a lot of interesting experience.
And in particular, with your background that you brought here, which areas were actually added to your knowledge in the program?
Yeah, so the first year of ITEP program that during my study, the first year was a group project which we built a pavilion, small scale pavilion project within a year altogether with all the classmates and all the tutors from PhD students and professors. So the second year we did master's thesis. So the first year, all it's a group project, right? So all students are from different backgrounds. So in my year, there are some people with structural engineering background and some people with the architecture degree for their undergrads. And for architecture, someone who are more familiar with programming, some are more familiar with the design, and there are also some students with the material engineering background. So we all kind of have our different roles in the pavilion design and construction. So we were separated into different groups, like structural design, fabrication groups who operate the robots for the fabrication and assembly. And I was in computational design, who was in charge of the programming part of the and creating the design tool for the designer of my teammates, and some other are studying the material. So everyone are sort of doing their own what they good at and contribute to that pavilion. So at the same time, of course, I also learn a lot from the others. So such as like some structural knowledges, some fabrication knowledges, material. So yeah, it's a new mutual way of learning and collaborate with others.
The program says that it wants to provoke a re-examination of techniques and practices and theories of design in engineering, in robotics, in digital fabrication, material science, and biology. And as you said, students come from very different backgrounds here together. If you recall what you learned back then about this re-examination of techniques that one has already under one's belt. Which of these techniques do you still work with today?
Yeah. So I had um, some experiences back in Taiwan to do some visual programming and programming, but I didn't have like very very much experience, I would say. Just I have some extent. I have some experience. So um, and during my ATEC, I met some of my tutors who are really good at programming their computer science background, for example. So so during the both the pavilion tool development and the classes and the thesis, I gradually improve much more of my skill in terms of coding and programming, so um, that I still use today. And also, I did study some geometry perspective, computational geometry during my study there, that I still also use today.
What is your current position at ANSYS company, and what is the focus in your work right now, if I may ask?
Yeah, so ANSYS, ANSYS is a simulation engineering software company. It produces basically all kinds of physics simulation software, um, and as you can imagine, it simulate all kind of physics for all kind of products, right? So from silicon like microchips design simulation to, for example, architectural structure simulation, or also for aerodynamic like airplane simulation, so fluid simulation like heat, or for example F1 racing car. If you want to have like really really fast racing car, you can simulate it, right? So that substantially reduce a lot of physical tests. So for example, the safety of a car crashing, you don't have to really crash a car. You can use really accurate simulation software to simulate it. So that is what ANSYS as a company do. They produce simulation software. So my current position is R&D engineer. So I do research and development within a group called Mesh Development Unit, which is we do 3D geometry, pre-processing 3D geometry for simulation. So in order to have very, very accurate simulation for the software, we need to have really good geometry in order to have a accurate result. So in that sense, 3D geometry, how we model it, how we discretize it, how we represented digitally are very, very important for simulation. So our group is doing a lot of research and development in this area, specifically for meshing in geometry. Yeah.
And how far, if at all, is your doctoral thesis related to what you are doing now? I think it's called stability assessment of discrete shell structures during assembly. And it was only done a year ago in 2023. So congratulations on that one. Please, can you talk about your dissertation, its objective, perhaps your approach, and also possible solutions that you offered?
Yeah. Thank you. So I got my as you mentioned, I got my PhD a year and a half ago, or roughly 2 years ago, back in Zurich. Because after Stuttgart, I worked there 2 years, and moved to Zurich. Did my PhD at ETH Zurich in a group called Block Research Group, and in this group, we particularly research a lot of uh, compression only structure, something like ancient cathedral, for example, a structure made by stone that good at bearing the compression forces, and then they are very, very strong with the compression force, and then stay a very long lasting structure, and then they are very also can be analyzed geometrically. So that is my previous boss, Professor Philip Block, group doing. So and my thesis dissertation specifically was also in this area. So to be honest, it's not directly related to my current job in ANSYS. So of course, I did study a lot of simulation, optimization, and geometry that can be like indirect use. This skill can be indirectly transferred as my current job, but it's not directly related. So, but my thesis was about how to it was about like a new method to a new mathematical formulation to simulate static structure, and the goal was to actually wanted to reduce scaffolding, for example, during the construction. So if you imagine, if you build a cathedral, or if you build a dome structure, or shell structure specifically, uh, during the construction, that you need a lot of support, like in order for the structure to temporarily stand during the construction, and the structure will stand very strongly after the whole structure is completed, and then the builder remove the scaffolding, which is the temporary support during the construction. So this is like all this process, all of the scaffolding is very, very wasteful and very time consuming. So my goal was find out the good way to construct the structure, a compression only structure, and help the designer to make a better decision, and also during the assembly. So eventually, at the end, uh, I realized that during my PhD, I realized I wanted to use some analysis simulation tool from computer graphics. It's a kind of a solver, static structural solver. It try to give you, if you give it the geometry, give very little like friction coefficient, and it will tell you if the structure is stable or not. So but during my PhD study, I realized that it has some flow. It produced some not accurate result, and you can put things upside down. Basically, it's still telling you it's the structure is stable. So yeah, I invested a lot of time during my PhD to improve this solver, to improve the to actually come up a new numerical, like mathematical formulation to simulate the structure. So that is actually the core of my PhD thesis. So I did a lot of I studied some and came up with some optimization, which is also pretty useful for my current role.
Thank you for sharing this idea about your dissertation. Now, I think we learned a lot already about 3D geometry. I wonder, these days there is often talk about the role of algorithms as well. Um, do algorithms play into your work more than 3D at this time, or how's that? How do you see that relation between the two?
Do you mean 3D and algorithms?
3D geometry and
3D.
algorithms.
Yeah, so they are super related. So they basically a lot of computational geometry or geometry processing. They are optimization or algorithm. A lot of things they are all kind of related. So for example, um, uh, if you want to project a point to a surface, or if you want to project a point to the curve, then behind the hood, if you use the 3D software, of course, there's just a button, right? Just you can click on the point, you can click on the surface, then the point project to the closest point. But behind the hood, they're all kind of numerical algorithm doing this and finding the closest point for you. So there are a lot of things for the 3D geometry in order to calculate 3D geometry computationally and correctly. So it's closely related.
In your understanding, what are some of the contemporary most challenging aspects for the built environment?
So I think in the building industry or construction industry, um, um, I mean, I think there are two problems. In my personal humble opinion, I think there are very serious problems. So first is construction industry, super uh, wasteful, I would say. They consume a lot of energy or of the earth. So if you see the carbon consumption, or actually the building industry is one of the most industry that consume the world energy. So every time you build concrete, you build a lot of buildings. Uh, yeah, it's just like a lot of these consumption. Yeah, so this is one of the problem. So the building industry need to build more sustainable and save our environment. That's for sure. So another important aspect is building industry is very insufficient. So they are very slow. They are not applying technology very fast. So compared to other industry like IT or car industry, well, I guess like that is because, for example, for cars, you can just design once and mass produce, and you can produce a lot of cars, and then you can sort of using a very efficient way of uh, building it, and that actually bring you more money. But in construction industry, all building kind of are different based on the size, based on the location, the weather, the solar consideration. So they are designed differently. So every time construction company or building industry try to build a building, or they design differently, and then they try to use different methods to build it. Yeah, they are very slow on technology, I would say. Yeah, and they are, yeah, very wasteful. Yeah.
You bring a lot of diversity and interdisciplinarity to the work. With a Doctor of Sciences degree, you mentioned it already, from ETH Zurich. You also are you have received the ITech degree, the master degree here in Stuttgart. You have a Bachelor of Architecture, I think, degree from Tam Kang University in Taiwan, and you have a lot of international R&D experiences. So what would you say about yourself? Are you a designer more these days? Are you an engineer more these days? Are you a scientist more these days? Has any of the three got an upper hand in you? Or is this, as you think and reflect about it, quite a good mix for you?
Mhm. Yeah, so yeah, as you described that I have bachelor architecture, and then I had iTech, more like engineering or architecture degree, and then after that working actually a construction company as a software developer. So and then I did my PhD in sciences, but I also during my PhD I also got a computer science degree, part-time computer science degree at ETH. And then yeah, and at ETH I will consider myself as a scientist, and I work with computer scientists. I work with structural engineer. I work with designers. So yeah, so that's yeah, how I would see myself as a multidiscipline, people with a multidiscipline or interdiscipline background. But I think currently I consider me as a engineer more, as I'm working as a research and development engineer position at ANSYS. But privately, I think I will still be a designer or a researcher, a scientist. But for professionally, I'm an engineer currently.
Well, we all have different roles, don't we? But thank you for that assessment. You have also quite an intercultural experience. You have lived in Taiwan, and Germany, and Switzerland, and now you live in Sweden. Um, you have decided for the moment to stay in Europe. May I ask why?
Yeah, well, this is part of also like um, just chances, and also like family decision. I moved here um, after my PhD with my wife. So she found a job here first at the first place. So I also was looking for the job in Sweden, but we also very enjoyed it, our life here. So we are thinking to stay for a while. And if you ask why, well, I mean, there's always pros and cons to live in different country, and there are some aspects you like it, some aspects that you might not like it so much. But so far, we enjoyed it here because work-life balance, I would guess. I guess the work-life balance is much better in Europe compared to Asia, I would say. Yeah. So that, yeah, that is part of the reason.
That brings me to your hobbies, perhaps as well. You listed swimming and cooking. We talked about as cooking as an engineer, reading, games, and dogs. Among those, what would you say? Is there one that is your favorite pastime, and why?
Yeah. So yeah, I used to like or do swimming a lot when I was back in Taiwan. I was part of a university swimming team, so I was kind of like a semi-professional swimmer. I did some inter college like competition. So it was a fun time. and I really enjoyed it. But yeah, yeah, maybe I should do more swimming nowadays to keep on my habit. Yeah, but now I also find other things interesting during my free time. I like video game. I mean, some of them are computer graphic. They are 3D. Especially enjoy like game that you can do 3D things. That is like the things that I really like. It's 3D geometry. So that whenever I play video game, I was also amazed by those game designer or game engineer, what kind of 3D world or 3D geometry they can create. And of course, I also enjoy. I have a dog, so I enjoy playing with my dog, teaching her, teaching them um, um, uh, what is the proper behavior, or how to train them. This is also pretty similar to engineering. You have to reward them at the correct time. You have to reinforce it, positively reinforce their behavior that you want, so such that they can do whatever command that you requested. So they can be polite, they can be gentle. So I think those things are amazing. So yeah, if I have a lot of free time or after work, I enjoy doing those things.
Thank you for sharing that. Also, professionally, now looking ahead, where do you see yourself in the future? Will it be at a studio on your own? Will it be at a company as you experience right now? Will it be more in architecture? Will it be in related areas? Are you thinking about what will be next? What will be upcoming for you in life?
Yeah, that is yeah, that's a good question. Yeah, we no nobody or no none of us know like what our future will be. But at the moment, I really enjoy working for my company. And Ansett has been recently acquired by another company called Synopsys. So it's EDA. It's an electronic design automation company. I guess in the future, there's still a lot of opportunity in this company as a simulation or chip design or different kind of industry combined. And it is a very big company, so there's a potential growth inside the company as well. I don't know. So I think so far I'm pretty happy with the current company. So yeah, my personally, I really enjoy 3D geometry and research. So yeah, so I think I will continue investigate um, the opportunity for 3D geometry and research in the future. So yeah, so right now at the moment, I'm not thinking of open my own company. So I think um, I will prefer to work for um, company uh, like my current one or a big company that has a lot of resources or a lot of good talents that I can work with, or a lot of good data or good people, good software. Yeah.
Thank you for looking ahead for us here today. Um, at the end of our conversation, we have something that we termed Moment 7. Now, moment means 7 questions, really, that we would like to ask you to answer as shortly as possible.
Okay.
I don't call it question, I call it moment. So there will be now moment 1. Spätzle or Maultaschen?
Ah, um, Spätzle?
Moment 2. One thing you could change about the world would be
If I can change the world, maybe um, invented some good medicine for poor people or animals, what that hasn't been really taken care of.
Moment 3. Do you have a media recommendation for us? A good book, a music, a movie that you recommend to our audience?
That is a good question. Well, yeah, I don't know. Recently, I liked one of the Netflix series called Squid Game. I like that.
Moment 4. The best advice that you have ever received was?
So about a year ago, my previous dog passed away, and then one of my best friend, he suggested me that yeah, I've done everything I could for him. Um, just that if I'm ready, I should give another dog who needs it home a place. So yeah, whenever we are ready. So because they also deserve a home. So don't let yourself sorrow for too long. Yeah. So if you're ready, give another animal a chance. So yeah, that's one of my great advice. Yeah, that I received.
Moment 5. If you recall, what was your favorite place at the University of Stuttgart?
Hmm, I don't know, maybe K1. So where our building or studio at, and yeah, we have I had a lot of great memory there, and there's also a nice Italian restaurant in front of. So that was amazing.
Moment 6. If you could start all over again, what would you do differently?
I don't know, maybe study math a little bit more, a little bit harder. So as a architectural student, I mean, as I study architecture in my bachelor, um, yeah, I think people didn't put mathematics as a very very serious um, or top priority. So I had to yeah, although I really love it, so I had to like spend a lot of my private time afterwards to catch up with all the mathematical knowledge. So if I could do something differently, I would maybe spend some time or requested university that architecture education should have more mathematical uh, um, lessons. Yeah.
And moment 7. Please complete the following sentence. Thanks to my studies, I know that.
Um, I know that I don't know, the world is different. That different from where I grew up in Taiwan, and I met a bunch of interesting people that brought me where I am currently.
Thank you for our conversation and thank you for sharing some of your professional but also personal experiences in life. Much appreciated, really. And wishing you all the very best for your future work and career in whatever direction you may be heading.
Yeah, thank you. Yeah, I was also very enjoyed it. Yeah,
And,
thank
and
you.
to our audience, please stay tuned for our next conversations that are always based on what is made in science. My name is Wolfgang Holtkamp. Have a great podcasting day. Goodbye and good talking.